Hi guys, welcome back to my channel. This is the series of blind curated 75 problems. So these are the interview questions which have been used in various interviews. So in this series now I'm going to solve the valid parenthesis problem. In the valid parenthesis problem, it's basically checking if a given string is a valid well-formed parenthesis. So basically what it means is if you're given a parenthesis like this, every open bracket should have a closed bracket. So they use three types of characters here, which is a parenthesis, a flower bracket, and a box bracket. So in this case, every open bracket has the closed bracket in its right position. So this is a valid or a well-formed parenthesis, whereas in this case, the parenthesis is not closed with another parenthesis, but it's actually closed by a box bracket. So that's the reason it's false. And in this case, the box bracket is present, but it's in the wrong position. So if this is inside the parenthesis, then it's a well-formed problem. So what basically the solution that they are looking for is something that can identify a well-formed and an ill-formed parenthesis in this case. So now looking into the solution, here I've used stack. This is a very similar, it's a very classic stack problem. So what basically anyone would do in this case is if there is any open bracket, they'll first push that element into the stack. So when they encounter a closed bracket like the parenthesis or the flower bracket or the box bracket, they check the top element of the stack. If that matches the same type of this closed bracket, then it is a valid and they pop that element off. If they are not the same, if they're not of the same type, then it would return, and anyone would return false. And then the program breaks right away, right over there. If not, we continue and check every single open bracket and the closed bracket to see till the end of the string. If we find any ill-formed, we return false. If not, we're going to return true. So I'll just demonstrate it very quickly using this notepad. So if you have a string like this, so when you're parsing each element of that string, so if you encounter this element, right, you push it into the stack. So now my stack, the top element on my stack is this one, which is this character. So now when I encounter this character, I pushed into the stack. So this is my top element in my stack. So now I have another open bracket. So I pushed it back into the stack. This is my top element in my stack. And then I found another element, which is my box bracket, open bracket. So I pushed that into my stack. So now I have the second part of the solution wherein I'm getting the closed brackets. In this case, I have this box bracket, which is a closed bracket. So now I compare it with the top element of my stack. These two are of the same type. This is the open and that's the close. So what I do, I pop this element out. So now I have only three characters here, which need to have a mapping characters on this side. So then my next element that I've parsed is this one. So does this have a similar open bracket in my stack at the top? True. So these two characters, so I pop this character and this has been parsed. So the next character that comes in is this one, and yes, I do have a mapping top character, so this one gets popped, and then the last character is this one, which has a mapping parenthesis. So that's how the stack is useful, so that you can find the mapping characters in your solution. I'm going back into the original solution that's been written. So it's a very similar stack implementation, as I've said. So there is a stack. This is Java stack. We don't have to go and write a stack. It's actually available in Java. So you just instantiate the stack data structure here. Check if the string is empty. If the string is empty, for sure it's valid. If not, start looping through the string to see each and every character. So if you encounter any of the open brackets, then push them into the stack. So that's what this step actually did. If I encountered any open brackets, I pushed them into the stack. So I have four characters in the beginning, and all of them are my open characters. So I push them all of them into the stack. So that's the statement that's doing. So it's pushing everything into the stack and it's continuing the loop. If I find any of the closed brackets, let's suppose, that's when I go and inspect my stack. If my stack is empty, for sure, I have a closed bracket, I don't have an open bracket, so I return false. If my stack is not empty and I pop the top character over there, and if the top character is not, the close bracket for this, the open bracket for this, then I return false. It's the same for the box and it's the same for the bracket. So it's pretty much the same code here. You check if there is a matching open bracket in your stack and your stack is not empty. In any of these cases, it returns false. If this after parsing the entire string, I have mapped my opens and my close brackets, and my stack is empty. Then I return true, else I return false. So there could be a situation where you've done the entire popping like this, wherein you have matching characters, but your stack can also have an additional character like this. When it has an additional character like this, you finish popping and checking, but you still have one character left in your stack, which causes it ill form. So that's why it's very important to check if the stack is empty. If the stack is empty, only it's true, else it's return false. This is the very simple solution for this problem. So I'm just going to run this code and then submit. So that's the solution. Thank you so much.